Hi. Hi, it's only like 12:30, so we're crushing this. We're doing like all of calculus in 4 hours. Woo! So I want to talk to you. So we just finished a slide. Well, I think you finished a slide on long division and um, we did some infinite FOIL and we did some subtracting from a half and all that. But if you have a series like this, you can also do it all with sigma notation. So I just want to make sure you understand this is really easy. So what you can do is x times, and for our sigma notation that we memorized for the must know quiz, this is x alternating series x to the 2n over 2n factorial. And this is literally all you're doing, because think about what you're doing. You're taking x and you're multiplying it through every single term of cosine as a polynomial. And when you do that, every single term goes up by 1 power of x. That's all it's doing. X times this, x times this, x times this. And so why not just do sigma notation for that and multiply this x to the first by this x to the 2n, and then you'll have a new series that will just look like negative 1 to the n gets unaffected, and then the power of x goes up by 1, and your 2n factorial stays the same. And if you don't believe that that is a good representation for x cosine of x, I want you to write out the terms of cosine of x and multiply each one by x, and then write out these terms, and you'll be like, she was right. Okay. For this one, it's really not even that interesting. I'm not sure why I'm doing it, because it's insulting. We're going to take the formula for sine of x, which is negative 1 to the n, and then it's x to the 2n plus 1, but instead of x to that, we're going to be the smart girl, and we're going to say 2x to the 2n plus 1 over 2n plus 1 factorial. And the 1/2 just goes in front of every single term, so just put a 1/2 there, or wherever. Just put a 1/2 in front of the whole thing. So this is going to be a polynomial approximation for 1/2 sine of 2x, which, if I just could be a broken record for a minute, is so much easier than taking a slew of derivatives of this and plugging in a center of 0 and looking for a pattern and writing the pattern as a sigma. So it's just really helpful to know shortcuts. Any questions, Ms. Basani?
No, you're doing great.
Thank you. Okay, this is the what's penultimate? Is that a word?
Mm-hmm.
The penultimate question.
Penultimate.
Penultimate, not pan. Penultimate question. Basani, I need your attention for just a minute. She's on her phone again. Okay. Do we know how to integrate e to the negative x squared? The answer is
I feel like that was on the integration B somewhere.
no.
I don't, off the top of my head, know how to integrate that.
Okay. Like if there was a 2x in front, we would know how. We'd be like, oh, use substitution. We can do that, right? But there isn't, and so we don't, actually. And I don't think it was in the integration B.
Eduardo or Allen, could you come to the front desk, please?
Welcome back to Boulder High School.
Allen, to the front desk.
Okay. So we do not.
Tune in later for a bonus video on how to integrate e to the x squared. Cool.
Oh, you do have. She has her.
I don't know
integration
whether
B.
I have it, but
Sorry,
I'll
I'm
figure it out for
insulting
you
her.
guys.
She probably does know how to do it, but we don't. Okay. So what we do know. Oh no. Oh my gosh, I messed up. I'm going back. Here, Yoni, we have a disaster. Amuse them, quick.
So I'm going to try to integrate e to the x squared. Well, there's a little bit of, oh, okay, never mind. Oh,
Are
yep,
we back?
we're back.
We're back. Sorry, folks.
But I swear to you, I'll make a video. We're gonna integrate e to the x squared when I'm really bored tomorrow. Cool.
Tomorrow? Oh
Yep.
my gosh. I'm not coming tomorrow.
Nope.
Okay. All right, so sorry about that, folks. E to the x is, and I'm not going to mess this up because remember that slide was wrong. You going back and fixing that slide. E to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. How many terms do I need? Well, I'll stop there. I'll decide later if I need more terms than that. Okay, next. What is e to the negative x squared as a polynomial approximation? What should I do, Busani?
Plug in negative x squared into the x positions.
Okay. Should I do this very slowly, or can we do this all
Do
really
this
quickly?
fast.
So we're going to plug that in here. We're going to get negative x squared. When we plug negative
Plus
x squared.
x to the fourth over 2 factorial. Let's go.
Wow. Wow. I feel shamed. I can't do it that fast. Tell me what's next.
X to the sixth,
Over what?
3 factorial.
Okay.
You got it.
All right. What should I do next? I'm trying to find. I have now got a series for this. What should I do next? I should integrate it. And this is why we learned. I'll put a dx there, but it's really kind of pointless. But this is why we learned how to integrate term by term and integrate with a series, because we do not have series for this. So let's integrate this. Term by term, people. Antiderivative, little help. X to the fifth over 5 times 2 is 10. X to the seventh over 7 times 6 is 42. Okay, so now we have an expression for the antiderivative of this. And what I'm going to do next is just add some bounds here. And add some bounds here. And evaluate.
So cool.
I know, this is like the pan ultimate example. Okay, so I'm going to plug in 1 to all of this, and I hope this is enough, and we'll find out in a minute. If not,
I
we'll go
thought you were
add
plugging in 1.
Indeed. Plugging in 1. I can't speak and do math at once at the same time. And then all of this minus nothing.
All right, guys, ready, go. Your common denominator needs to be 5 from here is not a factor of this. So 6 times 7 times 5 is 42 times 5 is 210. So you're using common denominator of 210. Let's go. 210 minus 70 plus 21 minus 5. 210 minus 70 is 40 plus 21 is 61 minus 5 is 56 over 210, which is 27 over 105. Is that what you have in your notes?
I did.
28.
I wasn't going to do that in my notes, but that's
Oh.
good stuff. Thanks. Good job,
I don't
everybody.
know if it's
clap
right.
for her.
It's probably wrong.
Fractions.
It's okay. You guys should do that at home.
No, it's all good. But look, I like this answer. This is great if it's right. And I wasn't following because I was so confused because I can't do fractions. But we're trying to approximate the error with less than 1/100th. And do you remember alternating series error bound? So my question is, here's an alternating series. I need an error of less than 100th. Can I stop here and say that's a good approximation, those two terms? No, because the next term, the next neglected term is the error. So if I stop here and say the sum, that this integral is about 2/3 by adding these together, that's off by 1/10, and that's not good enough. If I stop here and I say I can't do fractions, but whatever that number is, these first 3 terms, that's not good enough because it's only off by 1/42. Is this number that Ms. Busani just cranked out of her brain, is this close enough? And so,
Well, this number
unfortunately,
has nothing to do with any of this, though, because I just added up the first 4 terms for nothing.
no, you didn't, because this number that you got, if it's right,
Yeah.
is the answer to what the approximation would be.
Right.
But my question is that can we actually stop here? Because I made an assumption
Oh, I see.
because I was tired and I just
I see.
stopped at 3 and then I stopped at 6 and then I got
Yeah.
to 7. What if, do I need another term? And I don't know that unless I find the next term and make myself sure that it's less than 100th. Because
Which you are sure of.
by you stopping here, you're saying, I am sure that this next term is my error term and that it's less than 100. Can you guys be sure? And so like we should go back and just talk about it. The next term would have been x to the 4th over 4 factorial. And then what would have happened to it? It would have been plugged in
X
a
to the
negative x
8th.
squared, so it would be x to the 8th over 4 factorial. And then we would have integrated it, and that would be x to the 9th over 9 times 24. is not.
Yes.
And so that would be 1 over 9 times 24. And as long as 1 over 9 times 24 is less than 1/100th, which it is for sure, absolutely, then we have approximated this integral. And let's go on the assumption that her math is right, because I don't think I have a decimal answer, but I don't have a fraction. It was 0.74. So quick, check that.
No, that can't be 0.74. That's less than a third.
My sum says it's 0.74.
I did something really wrong. Wait, 210 minus.
Do you want me to write it?
Oh my god.
210. Sorry,
Minus
everybody.
7
70 over.
plus 20. No, plus 21. Minus 5. So 210 minus 70 is 140. 161. 130.
161 minus 5 is not 130.
What?
161 minus 5.
It's 156. I just lost a 1. Okay.
So it's 128? That's
No. So it's half of 156 is 78.
Oh.
It's 78 out of 105.
Oh, that's way closer to
Yeah.
0.74.
All right, guys, forgive me, but
I hope you all enjoyed
that
that
was-
that lesson on how to add fractions with common denominators.
I was pretty close by
That's
100.
super close. Okay, so in summary, the integral from 0 to 1 of e to the negative x squared, which I still say we can't do, and she still says we can do by hand, is approximately equal to, where is it? 78 over 105 with an error of less than 1/100th. So we're within 1/100th. If I have my decimal right, this is 0.74. So the answer to this integral is between 0.73 and 7.75, somewhere like that. So super close. We just integrated something we can't integrate. We evaluated it with bounds. All of this stuff using calculus, using all the steps, basically everything we've ever learned. There was maybe a little more with interval of convergence that I didn't mention to this problem, but I think e to the has an infinite interval of convergence, so it doesn't matter what our bounds are. But that's like a super epic problem, and I want you to take a moment to reflect on how amazing it is that we just did that by hand. Okay, now that you've had your moment to reflect, wait for it. We got to show them the slide they already saw because I showed it early.
Woo!
That's literally the end of calculus. Like, we have finished teaching you what you need to know for Calc 2. There's still a whole Calc 3, but don't worry about that. Yeah, that's it.
Cheers.
Come here, say goodbye with me.
We have
We're
2
gonna
minutes
miss
to
you
say
a
goodbye.
bunch. Okay.
Don't tune in for a video on me trying to take the integral of that, which will take me all of the coronavirus season to figure out that it can't be done, because probably it can't be done. But, you know.
Okay, well, we're going to miss you a lot, and we'll be emailing you all the time. And get your tracksuits ready so we can all be
That's right.
matchy when we come back. On April.
Hazmat track suit.
Hazmat tracksuit.
Hazmat track suits.
Love
We're ready.
you.